Good morning, everybody. We are the Capturis Knowledge Base team. My name is Jack Olson.
I'm Vaughn Johnson.
I'm Ryan Sherrado.
I'm Willem Borg.
And today we'll be sharing our progress that we've made so far with our capstone project.
There we go.
All right. I'd like to begin just by introducing our sponsors here. We have Tanya Kessel, David Eichley, and Roy Savelka. All three have been very helpful to us so far throughout this project, and also just very enjoyable to work with. We meet with them every Tuesday morning at 8:30, and to get four introverted, geeky computer science guys out of bed and ready for human interaction at that time, I think it says a lot about the energy that they bring every week and the experience that they have to offer. That picture up there is not actually any of our sponsors. That's from David's 100th birthday, I believe, where he had about 100 of those creations on his desk. I would put that on there, share that they like to have fun as much as we do, and once again, thank you for coming out here from Mandan this morning. So I'll begin by talking a little bit about NISC, or National Information Solutions Cooperative. They provide integrated software and hardware solutions for utility and telecommunication companies, as well as other infrastructure companies, Fortune 500, Fortune 100 companies. They've been around for about 50 years now, and they have over 20 million consumers who get their utilities and telecommunications through companies that use NISC solutions. So it's a very big company. And as a cooperative, they're owned by their users. So the member owners are very valued within their NISC community, and they operate on the 7 cooperative principles that you can see behind me, that essentially member owners enter partnerships based on trust, commitment to excellent service, continuous support, and opportunities for professional learning. Which brings me to Capturis, who has been with NISC for about 18 years now. And you can see the mission statement behind me, but an oversimplified high-level view of that is they provide billing services and bill payment services for utilities. So with their payment processing, they developed their own in-house first due, first through system, and that greatly minimizes the amount of late fees and disconnections that might be caused by missing payments. So they're very good at what they do. They also provide multiple processing options because they recognize that one size doesn't fit all, especially with time-sensitive things such as bill payments. And the reporting tools make them a lot more than just a bill payment company. They're able to have this very user-friendly interface that allows their business partners to see their overall usage and forecasting for their utilities and make sound business decisions based off that. Now, the business problem that we're addressing with our solution here is, so Capturis, when they interact with their clients, there's a lot of Excel documents, some of which include requests for proposals and security audits. The main purpose of these documents is to help clients make a transition to Capturis, or make sure that the Capturis security requirements are in line with customer needs. And if you take a look at these Excel documents, they're absolutely massive. They contain hundreds and hundreds of questions and answers spread throughout multiple sheets per document. And if there's multiple documents, this really adds up for a client, just massive amounts of data. And currently there's no way to historically see how these questions are answered from client to client without digging back into other previous Excel sheets. So in the short term, there's a need to more accurately document or more efficiently document these interactions between Capturis and their clients. But there's also a greater long-term need to aggregate all these answers together so that Capturis can provide the most accurate and helpful answers possible for each client.
All right, so I will be talking about the knowledge-based solution that we were implementing. Our solution boils down to we need to create a library that holds all the questions and answers that Capturis has. For that, we have been tasked to use a PostSQL database, and we were specifically tasked to have a editable table where each individual cells can be edited. And this library will be used as a future reference for all questions that Capturis may or may not have. Our implementation is a web application where users can store questions, answers, and other metadata such as information about the questions, who responded to it, when it was last updated, so things like that. The table will be able to be searched across all data by word or phrase. You can filter your search results by a specific column, and the web application, we leverage predefined lists when adding questions such as customer lists, source document types, etc. The interface design, we initially have a login page, which is just where users can log in before they have access to see the data. There is an administration page where admins who have privileges can edit customer tables, user roles, etc., and add users to the knowledge base so that everyone has access that they need. The main knowledge base page uses a NG2 smart table, which has built-in functionality for multi-column sorting and filtering, and also having the ability to create, edit, and delete content in the data source. And next, we'll talk about the database design.
Thank you, Ryan. So when I think of the most important database design principles, I'm thinking about usability, security, and performance. Our definition of usability in this case is having all the data and information being stored, being meaningful to Capturis itself. As requested by our sponsor, we worked with NDSU IT department to spin up a 31 gigabyte PostgreSQL server on campus. It's located on the NDSU network. The initial setup process for this was really straightforward with some help from Guy Hokinson, so big thanks to him, which allowed us to really focus on our data structure and its organization itself. That's unfortunate.
To sleep, he bumps the mouse or the keyboard when the PC wakes up. It automatically switches back over, so just...
Cool. So here you can see the current iteration of our data structure. This has been kind of a living document since literally days after we found out we were going to be working with Capturis for the semester. I believe that the lifetime of this kind of represents just how important it is to our final product that we're going to be delivering, as it's going to determine the application's performance. And on the topic of performance, our goals for the database include normalization to the third normal form, implementation of indexing for speed-ups of queries, and finally the definition of functions and triggers to help along automation of the actual database. Our goal for the normalization to the third form has already been achieved with our current data structure after many iterations of the document, so that's back to this one here. Now, if you're not a database nerd like me, you might think that's more computer science buzzwords, third normal form, but a simple explanation is that only foreign keys should be used to reference another table, and no other columns in the parent table should be existing within the one that you're referencing. So it's basically about duplication of data. You want that as minimized as possible. Within this diagram, you'll notice that that definition holds true. It's kind of a lot to look at, but it will hold true for all 15 tables currently. So continuing with performance, we have indexing. Indexing is just kind of the act of creating another small table with two columns in it. One has a key, so you can think primary key or foreign key in one of these tables, and then the other is a pointer to where the actual values are in memory. So it'll hold the address and just speed up because you know exactly where you need to look for a piece of data. Currently, we only have indexing implemented on the primary keys of each table, but we have plans of a more robust implementation in the future. And lastly, for performance, we have functions and triggers. We can see an example of this in the following slide. All right, perfect. You can tell I can use Atom, so we'll keep with these. In this implementation, we are defining a trigger and a function to update a specified column. So you can see up at the top, this is actually the trigger definition itself, and then for each row after an update to the database table itself, it'll execute the function below it. So that function will then check if the new record is different than the old record, and then update the last updated on value on the actual database table. So it just automates the process so you don't have to do it yourself in each of your queries. So we can see an example of this. The top one right there is just the initial insertion of a record within the database, all the times that it was created, the password. So this would be for a user. And then you can see after the record is updated, this center one will update with the new time automatically. And then if you reset the password or change the password on the user, you can see down at the bottom that it'll update the last updated and also password last updated on values. So this is all automatically happening due to this trigger and function. So it's something that's really important to just the automation and upkeep of the database itself, so you can see what records are being touched and when. Makes it really easy for in the future when someone else has to take over for us. So finally, we have security. Currently, our security plan on the project kind of revolves around principle of least access, not showing paths to these certain functions like our user setup functions, and then also, apparently I'm shaking too much or something. Just put this in. So obfuscating paths to which you can see the sensitive functions and triggers, and then temporary authentication solution. After the initial setup of our Postgres server, we created a new user with reduced access rights and added the team's public IP addresses so we can access from off the NDSU campus. This was sort of an issue for us at the beginning, but we overcame that with some setup of our actual server. The team is now able to leverage this account for connecting to the database and utilizing our super user account just for more administrative access. So, as it would be kind of a legal team's nightmare to grant 4 college kids access to their Active Directory, we elected to just create an interim authentication function within the Postgres database itself using the built-in PG Crypto module. So in this example, kind of a lot to look at. You can see we take input up in the top. We have a password and username taking in. Then we will declare a Boolean value and we'll return true or false based on whether the decrypted password from the user is matching the one that's currently stored in the database. So this is a built-in function that we're using in the meantime between Active Directory implementation. All right, and I think now Ryan's going to give a quick demonstration of the application. Oh wait, actually I have an example. So up at the top you can see the incorrect passwords entered. Not Willem Pass, very secure. And then the correct password down the bottom. And you'll return a true value to let the application know that you are allowed access into the application. Now Ryan will give a quick demonstration.
All right. So I would like to make a warning in advance. Our current UI is very rough. I spent quite a few hours last night trying to get live access to the database, which was unsuccessful. So currently we are just running off of mock data built into the application itself. And while this is setting up, I'm just gonna say a couple things. As I said before, it's pretty bare. We currently have the ND2 table module input, and it is able to read data. We currently do not have a functioning create function because for whatever reason the documentation for the NG2 Smart Table is very limited, and some of it has been deleted or lost on GitHub. So it's been quite difficult to find working examples of this. If I just bring this boy right over here, you can see how dense these tables are. There are a lot of columns that need to be displayed, and as a result of this, the styling has been quite condensed down. There's still, I think, another column on this other side here. But as you can see, we have built-in functionality to add a new one, which again wasn't quite functioning. But say this question down here at the bottom is no longer needed. I can just click the delete button. It'll ask me if I'm sure that I want to delete, just to make sure I'm not making any mistakes. And as soon as I hit OK, it's gone. Now this question up here, what if, say, there was an update to it? Again, the styling is a bit dense, but say that the location for this meeting has changed. So let's just say it went over to Moorhead, Minnesota. I can go over here, click the update. Are you sure you want to save? Click OK, and it has officially updated. And just as a quick demonstration of our login form, pretty basic. Currently, it does not redirect anywhere, but our future plans is to have this on its own separate page that users will be taken to first, so that if they are not allowed access, they can't see the data in the table. And now Willem is going to give us a brief demo of some database functionality.
All right. So.
It's on the other page. You gotta bring it over.
So How are we coming in? There we
There
go.
you go.
So where's
Buddies right down there.
all right? And you've. Actually, I'm just gonna show the video here.
Show the video.
Yeah.
They're both open. So if you just want to
All right. So really quick, just because NDSU campus is kind of weird with PG admin, we're just going to show a quick video of an actual database call here. So you can see this query currently is being used to grab just kind of a mock knowledge base page. It will kind of bring in the requester, the contact, all the information about questions, answers, sub-questions, and their sources, and aggregate it into one giant report here. So you can see how long it gets. This is actually querying all 15 tables at the same time, just to bring in all the data. You know, the wonders of third normal form. But you can tell this is probably a little bit small, but you get the requester name, the contact name, questions, sub-questions, and it really goes down into the database. And this is kind of what you want to see as a first glance of, hey, this is the full question, this is the full answer, this is who it belongs to, and this is who answered it. Then we have another little example of just an employee query. So this could be used by administrators to see the employee, their role, their access rights, and then some more information about them. So this is my record here, just kind of down in the bottom. It's a little bit hard to see, but you can get name on the left, email address, role, access level, and then kind of goes into some of the more personal information. Playing videos.
Did I bring it up over here?
So you can fix.
This is why you can't trust technology.
There we go.
Alright, and up next, Vaughn will be talking about some of our issues and, oh, this is me, never mind. I will be talking about some of our issues and risks. First of all, SQL injection. To be prepared for handling SQL injections, our team is utilizing prepared statements within the application and securing the database with abstraction of sensitive functions. This was somewhat, I wouldn't say difficult, but more time consuming to implement. So it took us quite a few weeks to get that implemented properly. Database integration is one of our big and current issues. We recently updated the Java file so that we could access the database just this last weekend, and I didn't have enough time to create proper calls to the database to get the live data. And scheduling has been kind of a big issue for us. At the start of the semester, we were looking over our individual schedules, and we had a lot of time where some of us were off, but other of us had class or work. So trying to figure out some time for us to actually meet was a bit of a challenge. And there is kind of a funny story that goes along with this. We initially decided for our weekly meetings to start at 5 p.m. on Mondays, and I had class until 4:50 on Mondays. But at that point, I thought it'll be fine. I'll just join in from Quentin Burdick. First meeting we had, I got quite a few complaints from my team about the noise in Quentin Burdick. So the week after, I decided to hold a meeting from my car. And well, let's just say that was a very short-lived experience, and we decided to move the meeting time back to 5:30. And now Vaughn will talk about our schedule, progress, and status.
Alright, so for the first part of this final section, I'd like to talk about our sprint schedule. We broke up into 4 sprints. The first sprint was the first 3 weeks after the group was formed, when basically we spent that on getting our environment set up and getting the database set up. After that, we moved on to sprint 2, and that was basically getting our basic functionality, what we have here in the demos, stuff like that. Working UI, displaying the data. Currently, we hope And then sprint 3 starts after Easter break or possibly during, but officially after, or not Easter break, spring break. And that's going to be basically adding in our roles, which is an advanced user and an admin feature. The advanced user is a user that's actually able to edit and manipulate the data in the table like Ryan showed in the demo. And an admin user is supposed to be able to edit the roles of all the other users, so that way you can either add in a new user or change a user to be able to edit the tables, because the base user is only supposed to be able to view the tables. After that, sprint 4, and that's when we're going to start working on our stretch goals. The first stretch goal we're hoping to get done is getting Excel able to export or import an Excel file rather than directly creating a data for the database and adding it in manually. Rather than doing that, we can just replace it with an Excel file, upload the file, and all of that would go right into the database directly. Moving on. So next I'd like to talk about our user story points. So in our first sprint, we evaluated the user stories to be worth about 6 points. Same with the second sprint. So currently that puts us at about 6 points per sprint. The way we have evaluated is that total we have 51 story points, which means we only have 24%, which would mean our velocity that we want is actually 20 points per sprint. But looking back at the way we evaluated our story points, we did not account for the amount of time that the story points would take, but rather the importance of, or more or less the difficulty of what these user stories were. So we're thinking about going back and adjusting our story points, because obviously we have a mostly working demo, and it doesn't seem like we only have 24% of the project done. So in reflection, we obviously want to improve our velocity anyways, regardless of if we think reevaluating would be inaccurate, or reevaluating would be beneficial because our story points are inaccurate. We also spent a lot of time on documentation during the first 2 sprints, like a lot, but I'm sure most of you are very familiar with that. So our next steps, as discussed, sprint 3, we're going to work on adding in the roles and being able to manipulate the tables a little more. And sprint 4 is obviously working on the stretch goals that I discussed before. We're probably going to work on reevaluating those story points so it's accurately assesses our progress a little more. And of course, as our sponsors always like to remind us, is we're going to continue sparking creativity. Any questions?
Yeah, I got one question. You mentioned earlier on in the presentation something about automating stuff in the database.
Mm-hmm.
What are some things that you want to automate that you haven't automated yet, or that you weren't able to?
Okay, so I guess we could do functions for things that are happening a lot of the time. So
Okay.
if you create a function for creating a question, rather than just having to rewrite the query over and over again, the database can store that, like, what actually happened with that and make it faster. But I guess other things would be all of our last updated on, created by, created on values in every table. We really want to have those automated, so then if anyone makes a change or if anyone updates any value in it, you can tell who, when, and just kind of things like that. I can't think of too many other things we want to automate exactly, but I think just generally functions for things that are going to happen a lot with the application itself. It's good to have them just set in the database.
Another reason for automating the last updated on, the created on, and created by is just in case, for whatever reason, one of the employees decides they have a vendetta against someone, they can't just go back and edit the data willy-nilly, just for a little more security on that point.
Typical question on like a research RFP from the government is, what kind of computing facilities do you have to support your work, which could be a 10-page answer. How do you deal with big answers?
Currently, our temporary solution is just to increase the size of the field in which you can view and edit the answers. Something to look for or to look at in the future would possibly be to create like a hyperlink to display the answer as its own separate page, so that you have the full thing and in a very readable environment.
If you, I'm thinking if you had a fixed space for every question that was huge because one question, maybe it's, you don't want to do it. Okay.
I suppose we could just create the cells so that are scrollable or something that you can just expand it. That'll be definitely something to look at in the future.
I guess I didn't get a full look at the database schema, but just the prior question where you mentioned we've got the last edit by. Are you storing a complete history of edits and changes, or just the most recent one?
Just the most recent one right now. I believe we didn't really talk too much about implementing an actual archiving portion, but I think we would implement that with another table and then have a trigger and another function that would be storing the actual records in there. So that would be one thing we can do.
Just in case you've got two people with a vendetta and they can conspire.
Yeah, I think archiving is a pretty easy one with implementation with our current function and triggers. It will just allow an insertion of the entire record into the archive table, and that will make it a pretty easy process if we choose to go that route.
So you mentioned decrypting the password. What kind of encryption are you using for the password?
So currently it's using a blowfish encryption. It's kind of a little bit of an older one right now, but it's using 6 iterations of that encryption. So it has a salt on it. As a temporary solution, I think this is all right, but we want to look for something more secure in the future, I suppose.
Yeah, I feel like we should be using a hash function where you can't decrypt. It's just take a password in, salt it, hash it. You can't get it back, and then compare that with what's in the database.
I agree with that.
Anything else?
I guess how's the GitHub coming along that I showed you guys? I think I've seen 2 or 3 branches.
With the branch that I initially started working on, Royce, you helped me out yesterday a lot, figuring out that it was in fact broken for whatever mysterious reason. So to fix that, I had to install an older version of the JDK, create a new branch, and pull from the master branch, which we knew was working. And I know Willem has a couple branches that I believe are not being used currently. Am I correct in saying that?
Yeah, I made all the database changes, have everything tested and merged it, so it's kind of a little inaccurate right now, I suppose.
Okay, so I'm just wondering. So I have seen branches from you guys. I'm wondering if you guys have been playing with GitHub at all?
So I attempted to pull off of Ryan's branch, and probably because it was broken, it wasn't working exactly properly. So the file that I was working on, I just sent directly to Ryan.
Yeah, and for the work that I've been doing, I've been pulling from Willem's branch mostly and then sending files.
Okay.
I think going forward, it would be ideal to have our own respective branches that we can work off of, and then push everything as we're doing it to the master branch, just to kind of keep everything in one place.
That sounds good. Yeah, because one person should be using one branch, and sharing branches should only be for debugging or emergencies, not for continued work.
Okay. Right.
Thank you.
Thank you guys very much.